Hello guys, in the today's class we shall discuss about polarized moving iron type relays. Okay, so let us try to understand how exactly the polarized moving iron type relay works. We can see since it is a DC polarized relay, so it works on DC only. But by making use of some rectifiers and all, you can even apply AC supply so that rectifier converts AC to DC. So you can make use of it. You can see that there is a coil which is wound over an iron and is placed between permanent magnet, and this is the hinge, this armature, moving armature, which is connected by a spring at the end here, which the spring gives here a restraining torque, and this is the coil which gives you operating torque. If operating torque is greater than the restraining torque, then only what? This hinge will move, that is armature will move, otherwise it doesn't. So whenever I give supply in terms of current here, let us say actuating quantity here is current. So what happens? The operating torque will be greater than the restraining torque provided by the spring, so that it moves, it's pulled inside, so that this contact is pushed up, so that it makes contact with this, and again due to this it is connected to the trip circuit, and trip circuit gets activated. Depending upon closing or opening the circuit will perform. Here such type of relays have sensitivity of around 0.03 to 1 milliwatt of sensitivity is there, even of small burden, very less burden VA, as well as by using some transistor amplifiers and all, we can even increase the sensitivity of the such relay to 1 microwatt, so less for pickup purpose. Even for that much of small variation in this actuating quantity, your relay will operate. Wherever the accuracy is required more, so we are going to use such type of relays. And one more thing, and the operating time of such relays is around what? 2 millisecond to 15 millisecond. Within this duration of time, the relay will operate. So here the polarization means to increase the sensitivity of the relay as compared to your normal induction attractor type relay or your ordinary attracted armature type relay. So such relays are very much sensitive because due to polarization. Okay. Now let's discuss about reed relays. Let us see construction now. You can see there is a coil here surrounding a capsule, a closed capsule, which consists of iron nickel strips or nickel iron strips. These are the strips. Usually they are open and it is called as reed. Hence the name reed relays. Okay, this is a closed sealed glass capsule in which we have nickel iron strips, which is normally open, and this glass capsule is surrounded by coil. Normally it is open. When the coil is energized, so a magnetic field is produced, so that these contacts will come closer and close the contact. These reed relays are very reliable as well as they are maintenance free. As far as construction concerned, it is categorized under electromagnetic relays, but service point of view, if I considered, it will be categorized under static relays. They are used for control as well as other purposes. Again, the input requirement, the energy required to energize the coil and all is very less. It's around 1 watt to 3 watt. And the speed of such relays is of 1 or 2 millisecond, 1 or 2 millisecond. And again, these relays are bounce free, means these contacts will not bounce. So they are normally bounce free and more suitably for normally closed operation. Anyhow, we discussed by normally open when there is no any coil energized, but they are suitable for normally closed. And again, heavy duty reed relays are able to carry around 2 kilowatt at 30 ampere maximum current or 300 volt maximum DC supply. So the voltage withstand capacity for insulation between the coil as well as contacts is around 2 kilovolt, whereas the open contacts can withstand up to 500 volt to 1 kilovolt. So this is what we have configuration as well as the principle of operation as well as the construction of the reed relays. Okay. Till now we discussed various types of attracted armature relays which was a part of electromagnetic relays. Now let us begin with induction relays. Induction relays are the relays which work on the principle of electromagnetic induction. So this electromagnetic induction is the same principle which single phase induction motor follows. Hence, it works on the AC itself, only AC current. Okay. So, usually we have two types of construction of such relays, induction relays. The one which has induction disc and the second one which has induction cup. This disc or cup is very much similar to that of rotor of single phase induction motor. Okay. So here the moving element acts as a carrier of rotor currents. Like I told earlier, it is very much similar to that. Now let us see the working of induction disc type of relay. That is induction disc relay. Here you can see a theoretical simple construction of induction disc type of relay. This is the electromagnet and this is the brake magnet and this is the aluminum disc which is free to rotate. And again you can see this is the coil which is used to energize your electromagnet with the plug setting multiplier. And again here current is the actuating quantity and again plug setting multiplier we have going to utilize so as to set the operating time of this particular relay. And you can see at this end one part of the electromagnet is shaded and other part is non-shaded. The reason why we are doing this is because of to have two fluxes of having certain phase difference. The reason why we are doing is because to have interaction of these two fluxes on the aluminum disc so that eddy current is produced. And due to the eddy current as well as the fluxes, what happens here? Torque is produced, and due to the resultant torque the disc starts to rotate. So you should remember the two alternating fluxes with respect to shading ring as well as the non-shading should be having phase difference of certain value so that interaction is possible, so that rotating torque is produced, so that disc will start to rotate. Okay. And again here the shading ring is of usually made up of copper. Again this brake magnet is also a type of an electromagnet which is C in shape. So due to this disc starts to rotate. And again remember there is a spring is utilized here so as to produce the counter torque for the resultant torque. Resultant torque is always against to the counter torque produced by the spring. If resultant torque is greater than that of counter torque produced by the spring, then only the disc starts to rotate, otherwise disc doesn't start. Okay. So such type of relays are robust as well as reliable, and usually it is used for overcurrent production. And here also induction type disc type of relays are used for that gives inverse time characteristics, inverse time current characteristic. and again, when compared with induction cup, they are slow in nature, as well as they are also slow when compared to that of attracted armature type relays, which we discussed in the earlier class. And again, this type of relays are used for usually slow speed relays, and again I told you the operating time is also adjustable by using plug setting multiplier.